All right, so let's see. So I actually enjoy teaching over Zoom for a lot of reasons. First and foremost is the ability to distribute files like this really quickly to everybody. There you go. That's the input text file. This file is a .txt file. It's a text file. It is a file that I alluded to about a couple of weeks ago. No, a couple days ago. Not weeks. What you talking about? I alluded to it a couple days ago. And what this is that it is um a file that served as an input file for one of my exam questions a number of years ago. Um, so you can click it and look at it. Okay. And let's see. See if I've got do I have the example output or no? Oh, yeah, I do. All right. And the goal is, let's see. I'm going to just go ahead and call this example output and I'll share my screen. Okay. The goal is to, there we go. That's going to look good. Okay. So our goal is to take the file on the left that I sent you all, the input.txt. Okay. Our goal is to take this. I don't need this. And turn it into this, where, so see how my personal email is this, all emails sent to, so over here, that bit about being redirected is not true anymore, but here we're looking at, but notice that we have some redacteds on the right, redacted, or andrew.rosen@temple.edu. So what is redacted here? What is redacted is any email that starts with TU something, 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 right? So this is today's example, and we're going to learn how to do this. Sorry, we're going to look at how do we do this? How do we create a script that removes some information from a file, a bunch of information that is just text from a file. All right. So we're going to look at how to do that. I think this is a very good kind of use of our time here. So I'm going to create a new file. I'm going to call it, it's not going to be a text file, all files. Okay. She left because I'm not petting her. So there we go. We are going to go ahead and we are going to just simply do, I'm going to call this. Good. I was double checking that I was screen sharing. Um, email replacer .py. All right. So you got my email replacer right here. Um, and on exam 3, which will be given during your last lab, and on the final, you'll have questions along this line where it is, hey, I've got some information here. I'd like to take this information. I just fix this. I've got some information here. I would like to take this information and I would like to redact some of it. Okay. So there we go. So the way this works is always the same. First thing we have to do is import RE. No matter what, we've got to import the regular expressions library. It's very, very simple. Next thing we need to do is that we have just a couple parts, basically. Load up the text. Do magic replacing. And create new output file. So over here, what we've got is that we need to load up our text. What does that mean? We're going to read the file. We're gonna read whatever this is. We're gonna take it into our into into our script. Next, do the magic replacing. Believe it or not, that's gonna take 2 lines if we split it up into 2 lines, which I recommend. And then the third part is we need to write a file to disk. Okay. So we already know the first part. Okay, so this is essentially just free points on the exam. Let's go ahead and we're given the name of the file. It's called input.txt on the questions. I often call it input.txt on the questions. So we'll load it up. Our text is equal to open input.txt. Got put that in strings. Read. Okay, so we're gonna go ahead and read. By the way, can everybody see this just fine, or should I make this more focused on this window, make this window smaller, and just zoom in on that window? Because I know that a lot of you are basically seeing.
I think the left side should be a bit bigger, but I could see it fine, but I think the
I've
left could
got
be a
yeah.
bit bigger.
What I'm gonna do, I know what I'm gonna do here. We are going to stop share for a second. I'm going to center this, and then I'm going to just share that. Okay, now that we're here, I can share just this. Okay, and I can
Thank you.
open. Pause for a second. Open folder. That was fine. Yes, save. So what we're gonna do is zoom. So what I did is I opened up the folder and you get to see all the random stuff I have on my desktop. But what we've got over here is we've got the email replacer now, but now I can easily go and open up the input file, but that also means we can go to and open up our output. So we've learned how to do this. And we don't need to go through this line by line for what we do. We just need to load it into text, so we can actually just chain this into one line. Or if you want, we can just, to make you more comfortable, we can just do this. Data is equal to open that. Text is equal to data dot read. Okay, we've learned, we know how to do that. 2 lines there. Now we're gonna go ahead and say, let's see. Now we need to create now we're gonna need to do the magic replacing. We're gonna skip that for right now because that's the interesting bit. So we're gonna leave it for last. Now, how do we create an output file? Not so hard. What we do is I typically do this. Output is equal to open, and then we need a name for it, right? The idea here is that we've got some input file, and we want to create some output file where the information has been removed. So the default mode that we've been doing is read. But if we want to create something, we would need to do the opposite of read, which is write. Very simple, fortunately, to do that. Okay? And then this actually becomes incredibly easy. And then it is ridiculously easy to do this. All we have to do now is say output dot write, and then we tell it to write a string and it will write that string. So I'm going to say, hey, let's just take the input and write it to our output file, just as a kind of a easy experiment for us to see how this works. And then the final thing you need to do is output dot close. This is to basically to close the file, to let it know, hey, we're done writing. You can close the file. Now it's saved, essentially. So if we run this, I want Python, not node.js. Okay. And now you may have seen it right over here. I had an output.csv, which was for grades. But over here, we just had an output.txt pop up. And it's the same exact thing we had as our input. And in case you don't believe me, here's what I'm going to do. I'm going to instead say apple, apples and bananas. Okay. Just as my output instead. I'm going to run that. And we see that it's apples and bananas now. So this is actually, so writing a file in Python is ridiculously easy. So we have used one line for the import, 2 lines to read, 3 lines to do this. So the magic replacing needs to take a long time, right? And the answer is no. I'm sorry, a lot of lines. No, it's not going to take a lot of lines. It's 2 lines. That's all we need to do the replacing. All right, ready for them? First, we need a pattern. The pattern is the regular expression, basically what target we're seeking. Let's go ahead and just say that we're trying to remove .edu, okay? Just, well, anytime we see a .edu, we're going to remove it. Remember, we put an R in front of our strings when we're working with regular expressions. The R stands for raw strings, okay? Now, why do we have that? Because I would have to do this. I'd have to double escape my escape characters, and that's very annoying. Um, so we're just going to just don't think about it too hard because you don't need to. Unless you really want to look into string formats, and more power to you. But most of you just want to learn a useful tool, right? So remember, R for regex. Slash period edu. Okay. So this will say, hey, I'm trying to match the pattern edu. Now, how do we do the magic replacing? It is just one command. In fact, if I test you on any commands, it's going to be one of two. We learned one already, re.findAll, which finds all hits for something. It finds all instances of that pattern and stores in a list. This one's really nice, re.sub. Okay, re.sub takes 3 things. It takes 3 arguments. Very easy to understand. The first is pattern, which is what we're looking for, right? It's the pattern that we're looking for. The second argument is what we want to replace that with. And the third argument is what are we looking in? We're looking in the text. Okay. So for right now, what I'm going to do is I'm going to just very basically show you that if I see a .edu right over here, what I'm going to do is I'm going to look for that pattern. I'm going to replace it with a bunch of underscores in text, right? And I'll store this as out text. Then all we have to do, so this creates a string that is this, but where all instances of this pattern have been replaced by this. Let's go ahead and see by printing out to the file. So anywhere we've seen a .edu, so here we have .com, so that didn't get replaced, but all .edus got replaced by a bunch of dashes. That's it. So why am I saying that's it? Because it's 1, 2, 3, 4, 5, 6, 7, 8 lines of code right there. Why am I saying that's it? Because for any question where I ask you the following, hey, I have a file and I want to replace all of X in the file with Y, where X is some kind of and you can make a pattern to match X. This is the answer. This is most of the answer right here. The only thing that changes is right here and right here. This is pretty much a freebie. I give it to you. I tell you I want it replaced with maybe redacted or a bunch of X's or something like that. Okay? There's more advanced things we can do. Like we could replace, like you can target things and just get only the first letter. So like you can replace like Mr. Rosen with Mr. R, right? And you can look into the Automate the Boring Stuff textbook for seeing how to do that. Right now, I'm just trying to focus on using this as a good kind of way of both showing you how to do this, because this is a very common task I could see you doing. And this doesn't necessarily have to be a file. This could be any text, right? So this part is just simply, hey, do you remember how read files? It's freebie points. Okay. This part, let's see, is our pattern. So this really is the only thing that changes between questions. If I were to say, hey, take a look here, I have a file with social security numbers, I would do this /d/d/d or three, because social security numbers, remember, social security numbers look like this. They look like XXX dash SSX dash XXXX. They look like all that, right? So here we would look for three numbers followed by two numbers followed by four numbers. Or if you remember how to use the quantifiers from the end of yesterday, right? What does this mean? It means three digits. Sorry, we were looking for a digit. Specifically, we're looking for three of them, followed by a dash, followed by a digit. I mean, two digits. Sorry, followed by a dash. And we're looking for another digit after that. I'm sorry, four digits, four of the preceding character. 3, 2, 4. And this would remove, and then we put this in. This is the only thing that gets changed. And now it works on social security numbers. Maybe you change the input file name and output file name to whatever they need to be. But those are the trivial changes. Those are the changes that are super simple to do. You don't have to think about them. Right? So now that we've gotten that out of the way, let's take a look at this. Let's look at our actual task and see how to do this. We want to remove all of we want to remove all TU something emails, right? All the at temple.edu emails that go with TU something, okay? So let's go ahead and figure out how to do that. So what we have to do is we have to make our pattern. So now let's take a look. And let's say we want to replace it with redacted. Okay. Whoops. I don't need to execute that. So we've got this string here. So the first thing we need, the easiest way to do this one is that we could start it from the beginning, but honestly, I'm just going to start from the middle because there's actually just two parts to this, right? There's two parts to an email address. There's the part before the @ sign, and there's the part after the @ sign. The part after the @ sign is really simple. It's temple.edu. We want to remember to do this because remember, if we use the dot, that means any character. That could have some it could have some weird results. This is technically what we need, although this would technically work. So now if we run this code just on the @temple.edu, well, that's the input. So let's go ahead and take a look at our output. Right, we see this. So let's take a look at our TU email addresses. So our TU email addresses are TU, okay, TU, some letter, and then 5 numbers, right? That's your TU ID. Or not TU ID, that's your TU email, right? Your TU ID is just a bunch of numbers. So that's actually not too bad to do. So first thing we need to do is put down a T and a U, right? And then we have all this other stuff between this and the ampersand. What's next? We need a letter. Now, one mistake that I would see here is that a student might go /W for But remember, /w is alphanumeric. That means you're giving me, that means that would register, that would look for an email that, sorry, that would accept an email that looked like this. TU11111 at temple.edu. That would not work because, sorry, that's not a proper email address. So we want to be as specific with our targets as possible, right? Why does that matter? Because I don't want you to do this. Because because I, I want you to remove only the targets, only the TU email addresses. If I don't specify that, I get a smart aleck who says, I'm going to do this, which, as you know, sorry, which hopefully you'll understand why that is the basically symbol for regular expressions. Dot star. See, right over here, use regular expressions for find. It's a dot star. What does dot star do? Not an infinite loop. Dot star. So the dot means any character, and star means at least zero of any character. So it grabs as much as it can, and then it replaces it, and then it continues. And you might go, well, technically that did remove the emails. Yes, but it also removed everything else that was useful. All right, going back to our thing. We need does that matter? Does that matter for this case? No. Only really matters when you have escape symbols. All right, let's go back to this. So, TU followed by a letter. How do we do a letter? A to Z. And then we're followed by 5 digits. So we could do 5 of these, but why? When it's like this, you're like, wait, is that 5 or 6 or 7? Well, not 7. Is it 5 or 4 or 6? Your eyes glaze sometimes, especially if you are prone to migraines or something. Not easy. So what we're going to do instead is quantify it. That's 4, 5. Because this is what this is. A TU email address is T followed by a U, followed by any letter, followed by 5 numbers at temple.edu. Let's go ahead and check it out now. We go to our output and we see over here that Professor Rosen's email is profandrewrosen at gmail.com. All emails sent to redacted are andrew.rosen at temple.edu. Right? We didn't want to just look for stuff before at temple.edu. Right? We wanted only to remove the TU email addresses, not the aliases. Why? Because I'm being arbitrary. He's not redacted, nor is his email redacted, although that would be funny if that were the case. So we removed all the target email addresses. And that's basically it for those. The regular expressions are extremely powerful tools. And they have, again, it's all you have to do is modify this. All right. Any questions about this before I move on? Before I start moving to another problem? Yes, I see one. Can I re-explain? Which part? Ah, dot star. Okay. Right. So with regular expressions, we have a certain number of symbols. Okay. We have meta symbols. In fact, let me go ahead and open up um, open up the web browser to regexer. Okay. And yes, I know you can't see it right now. That's going to change in just a second. There we go. So here's our regexer. We are going to, that's right. So anything. So regex again is everything between this. Dot means any character. Dot star means any. Sorry, it means at least 0 characters. So it matches this entire sequence. And then it stops because it hits an end of line. An end of line technically isn't a character. Then we go over here. It starts at the beginning of here, and then it stops because it hits an end of line. Again, end of line technically isn't a character. Right? This would match anything that is. Oh, this hit 4 matches. It hits this, this, and this. Right? It says anywhere where we have at least 1 character. So it matches this. You'll see that we got a warning when we did this, where it says it can return empty matches and in some cases infinite number of matches. Where it says, hey, you had 8 empty matches, right? Which is, and if you notice, they're hard to see, but you see these grayed out new line characters. Those are our empty matches. So dot star is pretty darn useful here. Okay. Oh, we've got plenty of time left. Why don't we go ahead and take a look at the extra credit homework for a bit and take a look at some of the more interesting stuff we've got in there. And let you start thinking about, I don't think I can give you um going through the file is its own trick, is its and appropriately it's its own trick. But we're gonna take a look. Our next lecture, yes, our next lecture is gonna be over trying to work with, I think, nested. I'm gonna do my best to work with nested um arrays or nested lists or something that allows us to do that. So loop and function exercises. Nope. We are looking for. Where is that? There it is, right in the middle. So we're going to look at this, at some of these initial questions. All right. How many words have no vowels? Right? How many words have no vowels? It's a very interesting question to ask that. Okay. Um, Now for our file here, right? This is our words.txt file. It is, as you can see, quite the extensive file. In fact, oops, it's quite big. It's making it, why it's making my web browser, it makes Canvas choke. That's hilarious. You'll want to download that and use it, right? And what it is that that's a spell checking file. That's how, this is the file that gets loaded up into RAM, I believe, that so that you can check it really fast to see, hey, is the word spelled correctly. Now, let's see. Pause for a second while I download this. Oh, it's just on the desktop. Zoom. Right. So let's go ahead and just kind of take a look at one of those, again, one of these questions in a little bit. Right. I need to switch what I'm looking at. Share. And new. Save. Extra credit. Not put. PY. Save. Okay. So import. What we're gonna do over here is import RE. And we're just gonna read and we're gonna go data is equal to text. Data is equal to text. We're gonna go with data is equal to open words .txt. Nope, don't need that. Read. Oh my. And then we're going to do text is equal to data.read. Now that would read the entire file in. And doing that has both benefits and issues in this context of where we're trying to find words. Let's take a look at what I mean. We want to find a word that has no vowels, right? Pattern is equal to, so let's go ahead and try making a regex around that. We need to do, let's go with A-E-I-O-U, right? This finds any vowels. This finds any number of vowels in a row. And that finds anything that is not any number of vowels in a row. Let's go with find, and let's go ahead and do re.findAll. And surely this will not end in tragedy. We're going to print it out. It's going to end in tragedy. You already knew that, though. Pattern. Text. Oh, that's not what we wanted. That's a lot of, mm-hmm. It's a lot of weirdness, right? So how do I find this? Well, what we've got is here is, and we've got an entire batch of stuff. There's a couple of different ways around it. The first thing we can do is put in these weird things called /b's, which stand for boundaries. That returns an empty string. Are there not any words in here that have any? That's interesting. Let's go ahead and see, though. Do we have X, Y? Nope, we don't have that. I feel like there's got to be some here that are start with. Got to be something in here. Hey, let's see. I mean, we can look. Invalid under regular expression, we can look and actually test our regular expression right here. It's not a bad way to do this. Not A-E-I-O-U plus, and what is it grabbing here? You can see here that what it's doing is that it's grabbing, yeah, anything that is not a vowel. Does that make sense to you? Why just doing, it's highlighting everything. Why just doing this part grabs everything that is not vowel. It's doing exactly what we tell it, right? So that's why I added the /b. /b basically says boundary. Now notice it's basically saying, hey, it ends with a series of consonants. It's any number of not vowels followed by a boundary. Notice that abjure is not protected. Sorry, is not there. It's protected because abjure. Similarly, /b is anything that begins. And so if I do, interesting. See, Bhagavad Gita, Uruguay. Yeah, technically those are not vowels. Very good. Technically, this file may not have any on vowels. I could have sworn it did, though. All right. Now, let's go and look at another question where we will get some answers. Now, how many words consist of only vowels? Oh, that's what I did wrong. Plus. Whoops. Oh, there we go. I had the wrong regular expression again. I was doing one letter. So I'm not sure why this was just not doing it for us because this should. Anything that's not AIOU. All right, what did I have here? I had slash B. I had the. Oh, there we go. Okay, so now we have a bit of an issue, but it's working. Now, what is this? A new line. By a bunch of that. How interesting. Al goal. This is fascinating. Fascinating that I'm getting two separate results from these things. Okay. So what we were doing over here again with words.txt. So the answer is 50. Let's see. We've got sticks, spy, sly, slyly, sky. Right? These are, once you think of them, you're like, oh, there are a lot of words without any vowels. So how do we go about counting them here? Well, the issue here is that we're reading this all into a file, and we've got all these new line characters just driving me nuts. So instead, what we're going to do to do this is that we're going to go and be a bit more, how to say, exacting about this. And we're going to just go line by line. Count. Or we're going to go with output. It's equal to, let's go with this. And let's see, what can we do? We've got our pattern. No, we still want our pattern no matter what. For line. In lines. RE dot, and there's a couple other ones. Match, I believe. Finds the try to apply the pattern at the start of the string, returning a match object if any was found. I want to avoid match objects if possible. Search. What does search do? Scan the stream by looking for a match pattern, returning a match object. Why match objects? Why do we have to do match objects? All right, fine. RE dot match pattern line. This is our match object. If M, print M. Very Pythonic right there. There we go. And there we go. That's very interesting that we are getting things that are... Ah, that's why. So it's looking for things that are not AEIOU. BitNet is certainly not AEIOU, even though it has I in it. Why is it matching that? Because it's capitalized. That's why. And of course, it wasn't case sensitive on our when I was using the find otherwise. There we go. We've got myth, nymph, nymphs, and so we can do this. These are match objects. What's important though is that we can use these to count something. So we can say, hey, if so first off, what does this if M do? Okay. Let me explain what it says over here. It says returns a match object or none. What type's a match object? It's this data over here. It tells us, hey, we found this in the string, and this is where we found the match in the string. Okay. That makes sense so far? It's not important because we can just print it out and read. Okay. What does the if M mean? Well, the documentation said if the match occurs we will have a match object. Otherwise, we'll have a none. M will be none otherwise. The value, and literally this none, which is the null variable. None is a falsy value, meaning that it just like, so notice how that got grayed out there, right? If you put, remember, if you put if one, it's going to be counted as true. If you put if zero, it's going to be counted as false. None is essentially a false. It means basically this is an empty object. Don't try to interact with it. Think of it like a black hole. It's going to suck in and crash your program otherwise if you try to interact with it. So if none, I'll print out. So sorry, if we do if m, it says if m exists, then print it out. So other languages, you might have to do checks like this. If m is not equal to none. Like you may have done this in Java if you took Java. If m is not equal to null. Okay. So now what we can do is we can say, hey, instead of putting this into there, we can do output dot append m. And then all we need to do at that point is print len output. And
Excuse me, sir, I had a question.
Sure.
So I typed in for line 3 data open words.txt. Every time I hit run on my thing, it says words.txt doesn't exist, or
What
specifically
what
no
program
file
are you
exists.
using?
Pardon?
What program are you using?
I'm just using Python.
No, are you using Visual Studio Code?
Yes.
Okay, so here's what you want to do if you've been working in Visual Studio Code and you need to work with files. Notice
Okay.
I have this thing over here on the left, which has the Explorer and has a list of files.
Okay.
Um, Visual Studio Code is very paranoid, if you haven't noticed, right? If you try to open up something, it tells you, hey, do you trust this file? Right? You've seen that, right?
Yes.
Yeah. So it's just paranoid, which is both great and very frustrating. So in order for you to basically basically if you just have a file open, it sandboxes the program. It doesn't look for files. Um, what you need to do is you have to do this. If you're working if you're working on a file that's going to be reading other files, you want to open up the folder. You select
Okay.
open folder. Here I selected open desktop because I'm on my desktop. And you notice how all the nonsense on my desktop is right over here, right?
Yes.
So now when I run it, it will do that. The other alternative you have is to do run without debugging.
Okay.
And that should do it.
All right. Thank you, sir.
So Adrian says, where's the file with words again? The file with words, um, there's one somewhere on your computer, believe it or not. But right over here, but you find it in assignments. On idle, you just need to make sure that you're working in the exact same location, right? Your words file, the word file, just like how you write with the Irma file, just like with the Irma program, you got to make sure that the file you want to read and the file you're working on are in the same location. Oh, okay, great. All right. So now what we're going to do, right, because it's going to look for a relative path. It's going to look for a relative path. And it says, if I can't find it in the area immediately next to me, I'm just going to throw up my hands and quit I'm not going to search your entire computer. Who knows where that's been? So see, so I'm going to go back to here to the regex and just so some of the problems is long story short of this, yuck, is I wanted to just kind of show you that maybe the best way to do this is to just like go line by line. And find all would work, but you'd be adding a bunch of empty strings and stuff like that. So how many words consist of only vowels? All right, let's go ahead and take a look at that. This is similar. How many words contain only vowels, and we're going line by line. And so basically, you can think of boundary as again these slash b's mean boundary. You can think of them as beginning of line, end of line, except it doesn't care which is which. Oh, sorry, I need to switch screens. Right, so now we want to look for how many words are only vowels, and this is a very easy switch. We just simply go from this to this. And let's go ahead and print out M as we're going so we can see um, what damage we're inflicting on ourselves. Nope, that doesn't seem right. That does not seem right at all. Right? IO? Let's go ahead and take a look. Once again, what we'll do is I will simply take our regex. I'm going to dump it into here. And it's considering these dashes. It's considering these tick marks to be vowels. And so the only one it sees is IO. That's interesting, fascinating. Right? Certainly there's got to be other words that are only vowels. No? Hmm. Well, we can also make sure that this is we well, to avoid the tick mark being counted, we can do boundary followed by anything that is not a tick followed by boundary. And I think this would help. Sorry. A vowel. Hmm. Anything that is, except no, that's not going to help. Oh, no, that will help. We'll count the tick in there just in case. We'll see. IO. Yeah, just IO. Interesting. Okay, fascinating. All right, next question. Let's go ahead and see. How many words when end with ION? Let's go with how many words contain a Q not immediately followed by a U, right? So how many words that contain a Q not immediately followed by a U? So we've got our boundary here, right? Q not immediately followed by a U. If we just simply look for, so first off, the reason we have these boundaries is that why did we need an M? Oh, if M. That's just over here. It's the same as over here. It's just it's so that we only print out files that it's only if it's to print out it's to only print out M if it has a value. Q followed by not U. Right? That's kind of what we are expecting to do. Um, 0 results. Pattern. Getting this for an error. Let's see what your error is. Unicode escape character. Interesting. Don't know why. I have no idea why you're getting a Unicode escape codec. Truncated. I cannot tell you why. Try try doing try doing try doing encoding. Let's see. Try doing encoding equals UTF-8. It's what I typically do when I find an encoding error like that. Except that's not an encoding error precisely. Is it? It's a Unicode error. You can try that and see if that works. Okay. First off, boundary. So first off, anything where we have a Q. If we simply round this should match all possible Qs, right? How many times we see a Q in a word? 223 times. How many times do we see a Q followed by not you? Now, this gets 0, which we know that is incorrect because we know Iraq is a thing. Okay. So what's going on over here? Well, the not Q is part of the issue because the Q occurs at the end of a word a whole lot. So really what we need to look for is boundary. Boundary. What we're looking for is any number of letters, right, until we hit a Q. The Q can be anywhere, right? And furthermore, let's go ahead and just make this easier for us because we also have Qatar. We're gonna add what's called a flag. RE dot, let's see, RE dot, ignore case. That's what we have to do to ignore case. That's gonna make it nice and easy for us. So B, any number of letters, 0 more letters until we hit a Q. And then let's go ahead and be explicit about this. Any number of letters from A to T. A to T, V to Z. Basically everything but a U. Right? Any Q followed by U. That is optional. Sorry. And then we're going to say, let's see, not immediately followed by a U. Okay. And I'm just thinking of the cases over here that I'm running into. Let's see. I have to finish. So yeah, let's go with this for right now. And then any number of letters from from A to Z as well. This is a good example of evil genie stuff going on. So here what we got. We've got, would you look at that, a bunch of words that have U's. And this stems from this. Because that question mark is saying, oh, the not followed by a U is optional. So if I run this now, let's see, we get 3. We have Iraqis, Iraq, and Qatar. Now it should also hit, um, now what's missing? What's missing is Iraq itself. Why is it missing? Right? This is why why a lot of times when you're running regex, you want to run it on known cases. Well, let's take a look at it. A to Z, right? Any number of letters until we hit a Q, followed by anything that is not a U, a Q, not immediately followed by a U, followed by any number of letters, right? Any of number of letters, then we hit a Q, then something that's not a U, then any number of letters. Any number of letters before the Q, followed by any number of letters. What's going on over here is that we're basically saying the Q must be followed by a letter. That's not always the case, though, right? Sometimes we have words that end with Q. I think I can only think of Iraq, but that's sometimes. So what we're doing is I gotta make this more complex. I'm gonna create an or. And what I'm gonna do here is very straightforward. Any of number of letters, begin the word, any number of letters, and then you hit Q. And then you're at the end of the word. And there we go. Oh, and there's our last one. FAQ, which is short for frequently asked questions. This one you may find, scary to get this one right or wrong. I'm actually for the first page, I'm actually less worried about you getting it right or wrong and more trying to get you to think. A lot of there will be cases that you do not think of for all these on the first page. For the next couple pages, though, of that one, there are issues that there are more definite answers. Um, you got Trank and a dozen more. Interesting. You should get Trank. Or is it only, or is it getting Trank, or is it getting Trank from Tranquilizer? Let's go ahead and see. You get Trank from Tranquilize. So why are you getting Trank from Tranquilizer? The reason you're probably getting Trank from Tranquilizer, okay, and this is the last thing I'm going to do before I dismiss class. As I mentioned at the beginning of class, I do have to cut this short because I have to go, because the entire reason I'm remote is I have to go and pick up my son from school. The reason you're getting that is because this is why we have the slash B's at the beginning and the end. That allows us to say, hey, I want the whole word. There's actually more specific characters for that, but those look even scarier. And I just prefer the boundary stuff because also you're using a big file. You're because we're using a because if you're doing the whole read as opposed to read lines, this actually can be helpful. Awesome. Great. So I will most likely be remote as well on Tuesday. Hopefully this was not too bad for everybody. Um, is there going to be quiz this week? I completely forgot about writing a quiz, so I guess not. I guess there'll be a quiz next week. All right. Take care, everyone. I gotta get out. I gotta get out of here. I
Thank
will
you.
I will upload
Thank you.
it onto YouTube like anything else.